This lesson will cover multiplying and dividing rational expressions. The learning goal is to multiply and divide rational expressions. And success criteria is you can factor and then correctly divide out common factors, you can multiply and divide rational expressions, and you can state restrictions on a variable. So multiplying and dividing rational expressions requires knowledge of factoring to simplify rational expression and multiplying fractions. Now the process of multiplying and dividing rational expressions is the same as working with rationals, fractions themselves. Now, recall that to multiply fractions, we can cross-cancel and then multiply straight across, but you can also just multiply right away and then reduce your fraction as well. So if we're multiplying 4 over 3 times 15 over 8, we can either multiply straight across, so for instance 4 times 15 and 3 times 8, that would give us 60 over 24. And then we would reduce this fraction by finding the greatest common factor between 60 and 24, that'd be 6, so that would be 12, so you could divide both values by 12, and then that would give you 5 over 2. So in this example here, we multiplied and then divided to reduce. You can also cross cancel. So if we have 4 over 3 times 15 over 8, cross-canceling means you're looking at the diagonals here. And reducing those values as if they're fractions. So imagine it as being 4 over 8 times 15 over 3. So cross-canceling, we can factor out a 4 out of 4 and 8, so that gives us 1 over 2. And then for 15 and 3, we can factor out a 3, so that gives us 1 and 5. And then 1 over 1 times 5 over 2, that gives us the 5 over 2 that we had previously. So really the only difference between these two methods is that one, you're kind of reducing before you do the multiplication, and the other, you multiply and then reduce. When you work with rational expressions, it is recommended that you use this method, dividing out common factors and then multiplying. So the steps for multiplying rational expressions are as follows. Step 1, factor the numerators and denominators if possible, then divide out any common factors, then multiply the numerators and multiply the denominators, and then state the restrictions on a variable. And remember, you must include any instance where a denominator can be 0, and include factors that have been divided or cancelled out. So let's look at these two examples where we want to simplify and state restrictions on the following. So first, we have 6x squared over 5x multiplying 15x power, x times y to the power 3 over 8x times y to the power 4. So for cross cancel, we can also vertically cancel as well. So if you have, for instance, 3 over 6, you can factor this down to 1 over 2. So there's a few ways in which you can approach this, but we'll start by cross-canceling. So looking at these values, let's change to a different color for a minute here. So to cross-cancel here, we can look at 6 and 8. We can reduce 6 and 8 to 3 and 4. And then we can cross-cancel the 15 and the 5. We can factor out here a 5 itself, so this becomes 1, and 15 divided by 5 is 3. And then we have these exponents as well. We can also work with these exponents. Remember the exponent laws. If we have, for instance, x squared over x here, now we're looking vertically here, we can reduce this down to x, and here we have x y to the power 3 and x y to the power 4. Here we can cancel out these two x's, and we can also subtract y to the power 3 minus 4 using the division exponent law. So that here, this would give us y to the power of -1. So here, this x will cancel that exponent 2. These x's will cancel out, and then this 3 and that 4, this can either become -1, or we can think of it as Remember that that's y to the power 3 is y times y times y. That's over y to the power 4, which is y times y times y times y. It looks like g's here. These three will cancel, these three will cancel, left with a single y on the denominator. So you can either leave it as y to the power -1, or you can leave it as an exponent of 1 here. This is one step a little bit further, because then we don't have to deal with the fact of converting a negative exponent to its reciprocal. So here, after doing a lot of canceling out, we have now 3x times 3y, so that's 9xy. Actually, you know what? Let's write out these expressions first, and after they cancel out, so it's not too much. We're not really skipping a step here, so we have 3x over 1 times 3y. Oh, sorry. So we actually removed this y here. This y is gone, so it's just 3 over 4y. So that caught my mistake earlier when I did that. So here, we now have 3x times 3. That's 9x over 4y. And now we have the state restrictions here. So our restrictions is anything we canceled out and anything on denominator. You can also just look at the beginning of the problem, and we have an x and a y in denominator. There's no addition or subtraction on these. So your restriction is that x cannot equal 0 and y cannot equal 0. Because if they are 0 themselves, then this would be 0. 0 times all of this would be 0. And if y was 0, then 0 times all of this would also be 0. So the restrictions are x cannot equal 0 and y cannot equal 0. So in some problems, you can do a lot of canceling out, dividing out common factors right from the beginning to reduce the problems as much as possible. Again, you can just multiply straight away and then cancel out afterwards. Both methods will work. It's just recommended that you do cancel before you multiply. Let's look at b here. In b, we have x squared minus 4 over x plus 6 to the power of 2, multiplying x squared plus 9x plus 18 all over 2x minus 4. There appear to be no common factors vertically in each individual expression. But before we do any canceling out here, we should factor these expressions. So we do have a difference of squares on the numerator here, so x squared minus 4 is going to give us x minus 2 and x plus 2. This is all over x plus 6 times x plus 6. I'm going to expand this bracket here. And this is multiplying. Here we have a trinomial. So this is x squared plus 9x plus 18. This is where we have two values, where we need two numbers that multiply to a times c and add to b. In that case, we are multiplying to 18 and we're adding to a positive 9. And that's going to give us 6 and 3, positive 6, positive 3. Oh, no, let's put down here, so 6 and 3 are our two numbers. So this is now going to give us the expression of x plus 6, x plus 3, all over 2x minus 4. And 2x minus 4, we can common factor a 2 right there, so x minus 2. Okay, so we have fully factored here, and the purpose of factoring here is we've actually found all the common factors of our original expression. And from this step, we can now cancel out any common factor. So what we'll notice is, again, there's no vertical common factors, but we can cross cancel here. We have x plus 6, which is common on these two fractions here. And notice how when I cancel these out, I only cancel out one of the x plus 6's from this denominator. That's because you can only do a one-to-one cancel. You cannot, for instance, cancel out this x plus 6 as well, because that means we would need additional x plus 6 brackets on the numerator over here. So you can only do a one-to-one cancellation when you are performing this step. And then we also have x minus 2 on these two brackets, which we can cancel out, and that then leaves us with x plus 2 over x plus 6 multiplying x plus 3 over 2, and here we can just go straight ahead and we can multiply, so that's going to give us x plus 2 times x plus 3 over x plus 6 times 2. But now we need our restrictions, so our restrictions here is we have a denominator of x plus 6, so here we'll have x plus 6, we need to set this not equal to 0, and then we also cancel out x minus 2. I don't have to do x plus 6 twice, as we already canceled that as well. I don't need to do it once here. So here, x cannot equal negative 6 when you move that 6 over, and here x cannot equal a positive 2. So when multiplying and dividing, or when multiplying expressions like this, it is very much recommended that you find the common factors. You factor all of your algebraic expressions, and then you cancel out from there. So you've actually been doing this step with fractions the entire time, actually. If, for instance, we had 6 over 8 here, and we wanted to reduce it, well, you've actually been doing this kind of behind the scenes. Where here we found the factors of x squared minus 4, the factors of 6 here, that, for instance, would be 2 and 3, and 8 could be 2 times 4. These 2's would cancel, and that would give you the reduced form of 3 over 4 from 6 over 8. So it really is the same process. You're taking out common factors and you are dividing them out. Now dividing pretty much works in the same method as multiplication, exact same steps. The only thing that's different here is you will have the reciprocal, where you flip and multiply the reciprocal of your second fraction. Well, yes, it's totally okay to cross multiply. It is recommended that you actually do the multiplication of the reciprocal. The reason being is just that you are going to encounter a lot of steps and a lot of values in these questions. So working with the reciprocal just allows us to kind of simplify or make the question look a bit simpler. Again, it's all up to you on how you approach these. So first things first here, we are going to, well, actually we can choose to factor or we can choose to find a reciprocal. In this case, let's factor first. So we have 4x power 3 plus 4x squared times y. There's really, we can only count on factor here. When we're common factoring here, again, we're looking for a common numerical value, which is 4, so we can take a 4 out. They don't share y, but they do share x squared, so we can take an x squared out there. So 4x cubed divided by 4x squared is just x, and then 4x squared divided by 4x squared is 1, so that's just 1y, so plus y. That's all over 2y. And then we can go ahead and just get the reciprocal in here as well. So on the top we'd have y squared, and on our denominator we would have 2x times x plus y times x plus y. I'm just expanding this exponent of 2 here, just so we don't mistakenly cancel the x plus y with that x plus y there, for instance. Okay, we can now cross cancel. We can also cancel vertically, but there's no shared terms on either fraction. By cross canceling, we can cancel out this y and one of these y's here. Remember, that's y times y, so we're just taking out one of them. And then we can cross cancel. We can take out a 2x from this 4x squared, so that'll take that down to 2. This exponent, taking out one of those x's, and we can also cancel out this x plus y with one of these x plus y's. So that now leaves us, we now have a 2x over 2 here, multiplying, let's use the multiplication symbol instead of the x sign. So multiplying, we have now a y, and we are over x plus y. So this step I can also cancel out these two 2's as well, and then that's going to give us, let's export over here, that's going to give us x times y, so that's xy over x plus y here. So as we work with these restrictions, it's a little bit different here. We have to work with a different kind of algebraic expression here. So our restrictions from the beginning, we have y in our denominator, so y cannot equal to 0. When we have our reciprocals, we could potentially encounter x equal to 0. Here we had x in the denominator here, so x cannot equal to 0. But we also have to deal with this x plus y. So x plus y cannot equal to 0. We have to manipulate this. So that means that x does not equal to negative y. If you shift this around, x cannot equal negative y, or y cannot equal negative x. So our three restrictions are y and x cannot equal to 0, and x cannot equal to negative y. So multiplying and dividing rational expressions, always factor if possible, and then be careful when you're canceling out that you are only canceling out common factors. And then at the end, always state your restrictions.